Hi guys, welcome to Simple Programming. In this video, we are going to see how to use Apache Kafka as a messaging service with Spring Boot application. Apache Kafka is a distributed publisher-subscriber messaging system which can handle high volume of data. It has high reliability and can be scaled easily. It is fault tolerant because the messages are persisted in the disk before sending to consumer to prevent data loss. It has high throughput and it can perform 2 million writes per second. What are the different use cases for Apache Kafka? Kafka can be used as a log aggregator, collect logs from different microservices. It is heavily used by Zipkin, which is a distributed tracing system. It can stream real-time data. It can also be used for event sourcing in microservices, where multiple microservices will be writing to the Kafka streams and these streams will be responsible to write to database. Before we go in, we need to understand few things about Apache Kafka. We need to understand what is a Kafka cluster, what is a zookeeper, what is a topic, what is a partition, what is a consumer group, who can be a leader, and what is the meaning of follower. A Kafka cluster is a cluster that has n number of Kafka services running in it. That is, these are individual servers. These individual servers are called as brokers. If a cluster has more than one broker, then it is known as Kafka cluster. And you can add a new broker very easily into a Kafka cluster. These brokers can scale individually and easily add a new brokers in it. Zookeeper is used for service registry that registers all these Kafka service brokers and it plays the part of routing the request from producer or consumer to the brokers. All data is actually stored in the Zookeeper and is replicated in the partitions. This way, data is not lost if a cluster goes down. Zookeeper has a record and will replicate immediately. This gives zero downtime for Kafka clusters. What is a partition? A server can be partitioned into n number of memory chunks or chunks, and these partitions are linked to topics. Topics are nothing but they are message channels. Data is stored in the partition, and if the partition is full, you can use another partition. What is a consumer group? Consumer group gives you an opportunity to group all your consumers together for better handling of throughput coming from the producers. Kafka has a concept of leader and follower node. A leader node is responsible for all read and write operations on the given partition. Each partition has one server acting as a leader. A follower node is someone who just follows the leader's instruction. If a leader fails, one of the follower will act as a leader. When a leader goes down, the follower immediately becomes a consumer, pulls the data and updates into its own data store. Before we move on, please make sure that you have Kafka installed in your local machine. You can install Kafka by going to kafka.apache.org site and you can go to the Quick Start section. Quick Start section is very useful to quick start your installation and you can easily run the Zookeeper and the server. So just follow the steps mentioned here, download the code, unzip it, start the Zookeeper, start the Kafka server. It's pretty much straightforward. Okay, so what I have here is I have created a multi-module project which is Spring Boot Kafka. It is going to have a consumer, model and a producer. The example that I'm going to show you is I'm going to have producer as a separate Spring Boot application, consumer as a separate Spring Boot application. When producer sends a request to consumer through Kafka, it is going to be two individual applications running in different ports. I have also created a model project because I'm going to send a student object from producer to consumer. I don't want to create a Java file in producer and again a student Java file in the consumer. I want to have it common for both the projects. Okay, so let us take a look at the form.xml of all the four projects. First, we have the parent form of our Spring Boot Kafka project. So I have added the Spring Boot starter parent dependency. I have added the web dependencies and the test dependency. The modules are listed in the parent form. Then let us go to the producer form. In the producer form, the same thing goes in. We have the starter web, we have the Spring Kafka added here, and we also added a dependency for our model because the producer is going to refer the model project through the jar. We are going to have the same setup in the consumer project also. In the model project, there's not going to be any dependency because it is going to hold only plain old Java objects. Let us go into our producer project and take a look at the configurations. There are two ways you can use Kafka in Spring Boot application. One is auto configurations and the other is do the configurations yourself, which is manual configuration. For auto configuration, you can use the Kafka template directly and send a message. You don't have to create a producer factory, consumer factory, listeners, all these things. But for manual configuration, you have to create all these configurations in the configuration file and use it. For production applications, it is always recommended you use manual configurations because it will give you an upper hand on different configurations available that you can manage yourself. Okay, so what I have here is like I have a property key which is Kafka boot.server and I'm getting it into a string variable. Then I have a bean for Kafka template. Then I have a bean for producer factory. You need to add a bean of producer factory to enable transactions in Kafka. So the producer factory will take input as the Kafka server. It's going to take a key serializer, a value serializer. The thing is, like here, the key serializer is going to be a string that is going to be your Kafka topic. The value serializer is going to be a JSON serializer. It's going to be a JSON object. Now let us move on. Take a look at our controller and our service class. The controller has a simple REST controller service which is going to accept a student object as a request body and it is going to send it to the Kafka sender. Let me open up the Kafka sender. In the Kafka sender, we have auto-write the Kafka template and we have received the Kafka topic name from the property file. And then we are building the Kafka headers for the message and we are using the Kafka template.send to send the student and header. Let us move on and take a look at the consumer. In the consumer configuration file, again I have a Kafka server details, I have a consumer group ID and a consumer factory and a listener factory. The consumer factory is for the consumer, which is to know that it is binding to the Kafka server. You mentioned the Kafka consumer group ID. You mentioned the key deserializer, the topic name, and you also mentioned the value serializer for the actual value. And you have to return it as a new JSON deserializer student dot class in order to Kafka to understand and convert the JSON object into a student object. Then we have the Kafka listener factory to listen to the messages sent from the producer. Let us move on and take a look at our Kafka receiver. The Kafka receiver does not have a Kafka template. The method is just annotated with at the rate of Kafka listener with the topic and the group ID. The method parameter will be student. Kafka will automatically take care of deserializing the message that is sent uh, in the channel and give it to you as an object. Before we move on, let us take a look at the application.yaml of the producer and the consumer. In the producer, we are going to say the server details and we are going to give the topic name and the server port. In case of the consumer, again we are going to share the server details here. We are going to mention the topic name and we are going to mention the consumer group ID. Before we move on and running the application, let us quickly look into the zookeeper.properties and the server.properties. These are the two important properties that you should know when using Kafka. So let me open up the zookeeper properties. The zookeeper properties as a key, data directory, and the client port and maximum client connections. Okay, the data directory is where the actual data is stored. Can you recall that I mentioned that your data is actually stored in the zookeeper? because if a cluster goes down, it can be easily replicated from the zookeeper. So the port is 2181. Let us move on and take a look at the server properties. In the server properties, you have the broker ID, you have the port mentioned here, and the one of the important thing is the log. Okay, so we have the log directory where the Kafka is going to store the logs for the server. Okay, so this is for one node. What if you want multiple brokers? It is quite easy. So what the only thing that you have to do is you have to create another server dot properties. You can rename this as server hyphen node one dot properties, and you can create another file as server hyphen node two dot properties. Copy everything from here directly. Change the port, change the broker ID, and change the log path. It is currently pointing to temporary directory Kafka-logs. You can rename this as Kafka-logs-node1, and in the server-node2 properties, you can mention as Kafka-logs-node2. This is how you create multiple brokers in the Kafka cluster. Okay, so let us start the Zookeeper server and then let us start the Kafka server. For this, what you need to do is, okay, so the command is sh/bin/ zookeeper server start.sh, and you have to add in the configuration properties also. Okay, the zookeeper has started now. Let us start the Kafka server. For this, again, sh/bin. Alright, the Kafka server is up and running. Let us go on to our code. Let me quickly start the server. We'll start the producer and the consumer. You can see here that our Spring Boot application has registered to the Apache Kafka server. So you would be getting this only when the registration happens successfully. If the registration doesn't happen, it will throw an error. So the server is up and running. Let's move on to our Postman and let's fire a request. I have the request opened up here for the student object, and let us try to send this to the Kafka. Okay, I have received data sent to Kafka. The status code is 200. Let us see what happened in the Kafka interface. You could see here we have a log here that my topic Kafka sender. So looks like the sender has successfully sent the message and broker has received it and has successfully sent to the consumer. Let us now move on to our Spring Boot project and take a look at the console. This is the Kafka consumer console, and you could see here the Kafka has received the actual data. The model has been received successfully. In case of the producer, you could see that Kafka has successfully sent to my topic Kafka sender. Before we wrap up, I want to quickly show you how data is stored in the Zookeeper. Let's move on to the temporary directory of Zookeeper. This is the log file used by Zookeeper to store all your data that is sent from a sender to a consumer. So this is where it keeps a track of all the data sent, so that if a cluster goes down, it will automatically bring up the data and create a new cluster so that data is never lost in a Kafka architecture. With this, we have come to the end of this video. I hope you would have enjoyed this video, and thanks for watching, and please subscribe for more such videos.